Here's an outline of Chapter 12. You can see we aren't going to take the third 9 weeks quiz, but we have a quiz after 12.2, 12.3 next time. We'll have a quiz, and then we'll have a quiz towards the end. We're going to do some review within the chapter. It's a difficult chapter, so we will have some periods dedicated towards review. All right. Then we'll have the test. When we test, we'll test over formulas, we'll test over surface area, and then the next time we'll test over volume. We're breaking it up so it's not so much at one time. All right, so chapter 12 is surface area and volume of solids. Our objective is to identify solids and their properties for this section 12.1. Vocabulary. A polyhedron is a solid that is bounded by polygons called faces. Okay? So the side of one of these shapes is a face. They enclose a region of space. This face is a rectangle, this face is a trapezoid, and so on. So then we have where the faces meet is an edge. Where the edges meet is a vertex. Any questions on labeling the parts of a polyhedron? So polyhedrons, some characteristics or some examples. This is a polyhedron. That's a rectangular prism. This is a polyhedron. It's a pyramid. So you've got prisms and pyramids. And then not a polyhedron would be something with a curved edge. A cylinder is not a polyhedron. And a cone is not a polyhedron. A sphere is not a polyhedron. Identify and name the polyhedra. Tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. Okay, so A, is that a polyhedron? Yes, it is. What kind of polyhedron is it? From our examples we just looked at. It's a prism. And yes, it's a rectangular prism. You name the prism on its bases that are parallel, right? So this is a rectangle. It's parallel to that opposite side. That's a rectangle. So we can call it not only a prism, but we can call it a rectangular prism. If these were hexagons, we call it a hexagonal prism. So this is a rectangular prism. Right, and number of faces. The faces, how many faces does it have? 6 faces. Number of edges, how many edges does it have? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Right? Anywhere a side meets is an edge. How many vertices does it have? Places where the edges meet. How many vertices does it have? 8. All right. Any questions? What would I call B? What would it be called? What's that?
Is it pyramid?
Yeah, it's a pyramid. What kind of pyramid? What's its base?
Octangular.
What?
Octangular.
That's not. It's not 8 sides. It's 6. That's hex. Hexagon. Hexagonal pyramid. That would be a hexagonal.
So if I started here 4, if I added 1, week 2 would be 5.
Pyramid.
6, 7, 8,
Right?
9, 10.
And so the number of faces. How many faces does it have? Yep, 7 faces. Number of edges. How many edges does it have? We can count them again. We've got the 6 in the hexagon. There's 6 there, and then each side coming down is 1. And there's 6 of those, so that would be 12. 12 edges. And then the vertices.
4.5, 5, 5,
How many vertices does it have?
6.5, 7, 7.5, 8 vertices, right?
That's, come on, you can count how many vertices there are. How many? Yeah, there's 7. 7 vertices. All right. Any questions? Identifying polyhedron. All right. Is this a polyhedron? Okay, what is it? Cone, right. Cone is not a polyhedron. It's got a rounded, curved edge. It's not a polyhedron. Okay, you guys go ahead and do these on your own. If you want to work with your neighbor, you can. Go ahead and name these as polyhedron or not, and then identify faces, vertices, and edges. All right. So number one, it is a polyhedron. It's a square pyramid. Has 5 faces, 5 vertices, 8 edges. Any questions on that one? Number 2, it's curved, so it is not a polyhedron. Number 3, it's a polyhedron. It's a triangular prism. The parallel sides are triangles. That's how you name it. The prism, which kind of prism it is, it's a triangular prism. Has 5 faces, 6 vertices, 9 edges. Any questions? All right, very good. Euler's theorem. Okay, the number of faces, vertices, and edges of a polyhedron are related by the formula. If you take the examples we've done, you can see this. The faces plus the vertices is going to equal to the number of edges plus 2. All right. The faces plus the vertices, the number of faces plus the number of vertices is equal to the number of edges plus 2. So when you add the faces and the vertices, that number should be 2 more than the number of edges. All right. So we're going to use this is then if we know 2 of the 3, so let's say we know the number of faces and the number of the vertices, then we can find the number of edges. Or if we know the number of vertices and edges, we can find the number of faces. You have to memorize this formula though. F plus V equals E plus 2. Here's an example. We've got, this is a square prism. The number of faces is 6. The number of vertices is 8. The number of edges is 12. Right? The number of edges is 12. Remember, an edge is not a face. It's the line where the faces meet. Okay, so you've got 4 on the sides, 4 on this end, and 4 on that. So I add the faces and the vertices, 6 plus 8. I set it equal to 12, add 2, and we get that. That proves Euler's theorem. All right. Euler's theorem in a real-world situation. Find the number of edges of the frame of the house. All right. So let's do. How many faces do I have? 7? Let's see. We've got the front and the back is 2. We've got 1, 2. The base and the sides. So that's 1, 2, and then 3, 4, 5, 6, 7. She's correct. There are 7 faces. So this is like a prism, but you wouldn't name it. You couldn't name it a rectangular prism or a square prism because its side is a composite, right? The parallel sides are a rectangle and a triangle, so we just call it a prism. So the number of vertices. The number of vertices in this shape. How many vertices do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 vertices. All right, so according to that, how many edges should we have? No, not 17. Faces plus vertices equals E plus 2. Yeah, you'd have 15. So it would be 7 plus 10 equals E plus 2. So that's going to be E equals 15. All right, any questions there? There's the work. Everybody has it? Okay. Cross sections. So if a plane slices through a shape, where it intersects the shape is going to create a cross section. Right? Have you ever seen those magical shows where they have a woman laying down and the magician, and she's in a box and the magician slices through her? Okay, that would be a cross section, part of her body that is sliced there, that shape. So this is a cross section. Right here, what shape do we form? Let's assume that this tan plane is parallel to the top and the bottom. What shape would we form from this cross section in A? What would that be? What shape would it be, Aaron? What's that? Cross section. The plane slices through the cube, right? It's parallel to the top and the bottom. What's this purple area? That's your cross section. What shape is that? Yeah, it's a square. Okay, that would form a square. So your cross section would be a square in A. Now we slice through the cube in a different direction. Now we slice through the cube diagonally. What would the cross section in this picture be? Remember, the purple area is the cross section. Eric?
Square.
No, it's not a square. It would be a rectangle because we know the diagonal is longer than the side, right? So it's a rectangle. So the cross section would be a rectangle. Any questions? Okay, that's it for today.